children, we are proceeding to a new section in vector algebra. We are going to write equations of a straight line. See, when you have a straight line in the XYZ axis with O as the origin, the straight line is passing through a point A. Let P be any point on the line. So to form an equation, I want to write equation about P. That is always R vector. OP I call R vector. R vector is what? That is my question. Now A is the given point. So OA I call A. P is any point on the line. P can be anywhere on the line. That I call OP equals R vector. The line is parallel to a vector B. So what is all given? A given point and a parallel vector. Now as I join AP and B vector are parallel. So that is the beginning idea that I am going to use. When AP and B vector are parallel, I will immediately say the cross product is 0. Whenever parallel idea comes, we remember cross product is 0. How to write AP vector? Second letter minus first letter. Or I will say OP vector minus OA vector cross B vector equal to 0. OP and OA we have given the name R and A. This we call non-parametric form. So whenever I say an equation, I represent in 3 different formats. Number 1 is non-parametric form. The same thing I can also rewrite like this. Whenever they are parallel, one vector is a multiple of another. So AP vector is a multiple of B vector. Multiple means 2 times, 3 times. So generally I write T times. So R minus A equals T into B implies R vector equals A plus TB. This we call vector equation in parametric form. Now the same I want to extend for X, Y, Z. Generally calling P vector we call any point. So it is X, Y, Z. And A vector I can call X1, Y1, Z1. P vector I call X, Y, Z. A vector I call X1, Y1, Z1 in point form. So how to write R vector? Xi plus Yj plus Zk. How to write A vector? X1i plus Y1j plus Z1k. B is a parallel vector. For that also we give the components B1, B2, B3. So how to write B vector? B1i plus B2j plus B3k. As I substitute, let me compare. Compare what? I, j, k in both the sides. Here the I component is x minus x1. X minus x1 equals to t into b1. Similarly, j component y minus y1 t into b2. K component z minus z1 t into b3. From each of this, let me divide and get what is t. The right hand side is only t. All are equal. Implies LHS is also equal. And so I arrive at x minus x1 by b1 equals y minus y1 by b2 equals z minus z1 by b3, which is termed as the Cartesian equation or symmetric equation. Can I do the same for a line passing through 2 points? Now the line is passing through 2 points. Let me call one is A, another one is B. It is the same as our XYZ axis. X, Y and Z and this being the origin. Again we shall take P is any general point. join everything. OA I call A vector, OB I call B vector, and OP I call R vector. Now using this idea, which is parallel AP parallel to BP also. AP vector parallel to BP vector also, or AB parallel to AP vector also I can say. However, I can say AP parallel to BP, AB parallel to AP. Any three ways I can write. So how shall I write it? So AB vector parallel to AP vector, or I can say AP vector cross AB vector is equal to 0. So what is AP vector? Second minus first. So P minus A, that is R minus A. Cross. What is AB vector? Again second letter minus first letter. B vector minus A vector equal to 0. So this I will call non-parametric. So one pattern over. The second step, this idea, AP vector can be written as a multiple of AB vector. So whenever I say parallel, there are two ways of writing. Either cross product 0 or one vector is a multiple of another vector. What is AP formula? It is R minus A. What is AB formula? It is B minus A. Now I can bring A to the other side. R vector equals A plus T into B minus A. This we call parametric form. Now I extend. Wherever R is coming, put Xi, Yj, Zk. Wherever A is coming from this, let me put X1i, Y1j and Z1k equals T into B minus A. Second point minus first point. B I can take X2, Y2, Z2. A I can take X1, Y1, Z1. So when I subtract, it is X2 minus X1 into I, Y2 minus Y1 into J, plus Z2 minus Z1 into K. As I compare like the previous pattern, X minus X1, I component, X minus X1. By B1 I have, instead of B1 here I have X2 minus X1. Similarly, Y minus Y1 by B2 I have, instead of B2 I have Y2 minus Y1. And the third is Z minus Z1 by Z2 minus Z1. So this format we call Cartesian equation. So this particular exercise we are learning two different formats. A line passing through one point and parallel to a direction, or a line passing through 2 points. What all we should remember? Points I take A vector and parallel direction I have taken B vector. Here both the points I have taken, one as A and the other one as B. Let us remember direction comes with T vector, or direction comes in the denominator. A major idea to remember, point comes in the numerator, direction is with T vector, or direction comes in the denominator if it is Cartesian format. So whenever 2 points are given, what is the direction? That is nothing but the denominator. X2 minus X1, Y2 minus Y1, Z2 minus Z1. A great idea to remember whenever you are given 2 points in objective type. If you want the direction, direction is nothing but the difference of the points. Second point minus first point, or even I can write first point minus second point. So generally remember, direction when 2 points are given is nothing but difference of the 2 points. Now there is yet another idea. When you have two different lines, what is the angle between them. Say this line is R vector is equal to A plus TB vector. The other vector is R vector is equal to C plus say some other letter S into D. So how many lines I am getting? 2 lines. 2 lines are represented like this. Which is the direction? B is the direction here. D is the direction here. So always remember with T, with S, with the scalar whatever is coming represents direction. The other one represents point. My question is what is theta? So theta is equal to cos inverse. It is the angle between the directions. How many directions are there? B, D. 2 directions. Between 2 directions, what is the formula? Already we have learnt it in 11th standard. Between 2 vectors, same idea. So B dot D by mod B mod D. Now we consider only the acute angle. So put modulus here also. So this exercise we are going to do 3 different models. The first model is line through A vector parallel to B vector. Second model is line through 2 points A and B. And the third model is combining both, angle between the 2 lines. The major ideas to remember: point will come in the numerator, direction will come in the denominator. Direction will come along with T. Direction will come along with TS like that. When 2 points are given, difference of the 2 points is nothing but the direction. So having this in mind, let us proceed with the exercise. Exercise 6.4, question number 1. So given a line is passing through and parallel to. These are the 2 words that we have to be careful. Line passing through what is nothing but point. Parallel to what? That is a direction. We need to find non-parametric and Cartesian equation. So passing through, we generally take A. So A vector is equal to 4i plus 3j minus 7k. And direction we take B vector equals to 2i minus 6j plus 7k. Let us remember the formula. 1 point, 1 direction. Non-parametric formula is, so we write the non-parametric equation is nothing but r minus a cross b vector equal to 0. R we write as it is. What is a vector given in the question? 4i plus 3j minus 7k cross b vector. What is b vector? 2i minus 6j plus 7k, and that is the answer, equals to 0. So non-parametric is over. Next I need to find out what is the Cartesian equation. What is the Cartesian equation formula? We said x minus x1 by b1, y minus y1 by b2, z minus z1 by b3. In this question, call this as x1, y1, z1. So x1, y1, z1 is nothing but the point without ijk. Let me write 4, 3, minus 7. What is b1, b2, b3? Denominator represents direction, d, d. Remember, denominator starts with d. Direction starts with D. So denominator represents direction. Direction is nothing but 2 minus 6, 7. Now that I know what is x1, y1, z1 and b1, b2, b3, substitute. X minus x1 is 4 by 2. Y minus y1 is 3. b2 is minus 6. Z minus z1. Minus of minus 7 is plus 7 and b3 is 7, and this is the answer for the Cartesian equation. Denominator should not be 0 in any of the max problems. But in this exercises alone, we may have denominator to be 0. That can be ignored because it represents only direction. 0 implies that particular direction is not in that axis. Question number 2. Line passing through -2, 3, 4 and parallel to another line is given. When they give a line equation, denominator represents the direction. So, the previous problem they gave direction directly. Here it is given parallel to a line. Before writing the denominator, ensure that the numerator is with +x, +y and +z. Notice our equation will be x minus y minus z minus pattern. Here it is -z, which is not correct. So let me rearrange this as z minus 8 by -6. Throughout I am changing the symbol. So whenever they give 8 minus z, 3 minus y like that in the question, immediately rearrange like this. These two are unaltered because equal symbol comes here alone. All the three terms change the symbol. +z -8 by -6. Now direction is nothing but the denominator, and that I will call B vector. So what is B vector? -4i plus 5j minus 6k. And what is the point? That I take as A vector. That is -2i plus 3j plus 4k. If they give point, you write A vector by putting I, j, k. If they give you I, j, k format, you write a point by putting commas. Instead of I, j, k, put commas, that is point form. This is vector form of a point. Now I know A and B. The question claims us to find the parametric form. What is the parametric form? When they give you A and B, 1 point, 1 direction. The parametric form is R vector equals A vector plus TB vector. R vector equals A is -2i plus 3j plus 4k. Plus T into B vector is -4i plus 5j minus 6k. So this is the parametric form. We also need to find the Cartesian form. What is the Cartesian form formula? It is x minus x1 by b1 equals y minus y1 by b2 equals z minus z1 by b3. It is x minus x1. Instead of x1, I must write what they are. So x1, y1, z1 is nothing but the given point -2, 3, 4. What is b1, b2, b3? All the denominators -4, 5, -6. -4, 5, -6. See, if you don't change here, you may tend to put +6, which is entirely wrong. So whenever you are reading a line equation, ensure that x, y, z are positive. Now put this back in Cartesian form. X minus of -2 is +2 by b1. Y minus of 3 by b2 is 5. Z minus 4 by b3 is -6, and that is the Cartesian equation. Question number 3. Find the points where the straight line through 2 points are given. So take the first point as x1, y1, z1. That is equal to 6, 7, 4. The second point is x2, y2, z2. That is 8, 4, 9. They have not asked you parametric, non-parametric or Cartesian. But my question claims cutting point I want with the x, z, y, z and all. In this case, Cartesian would be easier. So what is the Cartesian equation? The formula when 2 points are given. The Cartesian equation is x minus x1 by x2 minus x1 equals y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. So let us substitute what is the 2 points given. x1 value 6, denominator is 8 minus 6. Y minus y1 is 7, denominator 4 minus 7. Z minus z1 is 4, denominator 9 minus 4. Simplifying this answer, x minus 6 by 2, y minus 7 by minus 3, 4 by 5. So we get x minus 6 by 2 equals y minus 7 by minus 3 equals z minus 4 by 5. This is the required line. But what is the question? Cuts xz plane. Whenever we say cuts xz plane, it represents y value to be 0. For example, in two-dimensional geometry, y-axis means x value 0. X-axis means y value 0. So, xz plane means in that plane, y value will be 0. YZ plane means in that plane, x value will be 0. So, to put that y or z to be 0, what I need is take this line as some new constant t. This we only say, so write say. Now, hide these two. Write what is x from here? 2t plus 6. So, how do I write the x value? 2t plus 6. Similarly, hide x and z. I want y value. So, how will I cross multiply? Minus 3t plus 7. Minus 3t plus 7. Similarly, hide x and y. What is z value? 5t plus 4. 5 into t plus 4. So, this particular point lies on the line. My question is the line cutting xz plane. So, xz plane implies. So, we will write cuts xz plane implies y coordinate should be 0. What is the y coordinate here? Minus 3t plus 7 equals to 0. Or this implies minus 3t equal to minus 7 or t is equal to 7 by 3. Put 7 by 3 in the point. So, we are going to substitute t equal to 7 by 3 in 2t plus 6 minus 3t plus 7, 5t plus 4. As I substitute 2 into 7 by 3 plus 6 minus 3 into 7 by 3 plus 7, 5 into 7 by 3 plus 4. Simplifying this answer, I can cross multiply. 2 7s are 14, 3 into 6 18. 3 cancel, minus 7 plus 7 0. This is a reason why it cuts xz plane. 5 into 7 35 plus cross multiply 12 by 3. So, I get the answer to be 14 plus 18 is 32 by 3, 0, 35 plus 12 is 47 by 3. So, this is the point where the line cuts xz plane. Now, the second part of the question is, first part is cutting xz plane. Second part of the question, line cuts yz plane. What does this implies? YZ plane implies x value 0. So, in the point 2t plus 6 I put 0. That implies 2t equals minus 6 or t is equal to minus 3. Substitute t equal to minus 3 in the same point. So, any point on the line only we have written. So, in this 2t plus 6 minus 3t plus 7, 5t plus 4, we substitute t equals minus 3. 2 into minus 3 plus 6, minus 3 into minus 3 plus 7, 5 into minus 3 plus 4. As I simplify, this is 0, comma 9 plus 7, 16, minus 15 plus 4, minus 11. So we get the answer 0, 16, minus 11. The line cuts YZ plane. 32 by 3, 0, 47 by 3. The line cuts XZ plane and hence the problem.